All right. Hi, everyone. I'm John from Group 2 of MET 313. And I'm going to be going over an explanation on how Bernoulli's equation works real quick. So, this is Bernoulli's equation written out. The first thing you'll probably recognize about this equation is that it's symmetrical. So, everything on this side is equal to everything on this side, and the values are the same. It's just like P1 versus P2, right? So, that's important because this is effectively an energy balance between an inlet and an outlet. Our equations our variables are written out here, but we'll go over each segment. So here we have the pressure. This is your pressure energy in this section here in purple. This here is your kinetic energy. And then right here is your potential energy. And you can see that these are basically like the same, like, oh, mgh, right? It's rho gh instead, because this is just the density. So again, just an energy balance. Like I said, we have pressure, density of the fluid, velocity of the fluid, gravitational constant, and the height of the fluid. So a few assumptions that are really important to making this equation work. First of all, it works significantly better in SI units. I'm pretty sure it might only work in SI units. Don't quote me on that. We assume that this is an incompressible fluid. That means that the density of the fluid here does not change with pressure. So this is really important because if you had these sections changing with pressure here, you're not going to have enough information to solve this equation. For the exact same reason, it's one inlet and one outlet. Again, that's very important to understand that you're not going to have enough information to solve this simply if you don't assume these things. It's also in steady state. And steady state just basically means that all the fluid that means that all the fluid properties at a given point don't change with time. Yeah. Don't be thinking it changes. Just it's the same fluid going in as going out. So moving on down here, I have a little bit more of a practical example to gain intuition. Let's say this is like your garden hose, right? You're putting your finger. Look at this beautiful finger I drew. I swear my nails are not that black. I don't have a problem. All right. So the fluid goes in here, and you got your fluid, and you put your finger over your garden hose, and it goes. It speeds up, right? It sprays really fast. And the question is, why does that happen? And can we explain it with Bernoulli's equation? Yeah, we can. So I kind of drew it in more of like a traditional like pipe sense in this section here. So we have our fluid coming in, and it is at a pressure of something. We're going to say that this is gauge pressure, by the way. And it's going to go and vent to atmosphere. It's our outlet here is going to atmosphere. So all this fluid is just spraying out to the ATM. You know what I'm saying? So we're going to say this is gauge pressure. So we're going to assume that we're going to say that atmosphere is 0, even though obviously atmosphere has a pressure level, but this gauge is going to just not account for the atmospheric pressure. Like if this was exposed to the atmosphere, it would go to 0, basically. So what we can say now, because of that, is that obviously there's a pressure here, but in this section here, this goes to 0. Now we can also look at our other terms here, and we can say, all right, well, I don't really think there's going to be a big potential energy difference in our sections here, right? So if you go from one height to another, it's probably going to be like 2 inches. It's not super significant. So now we have 0 plus our our kinetic energy plus 0 on this right side of the equation here. Which means that all of the pressure energy and all of the kinetic energy that's in this section of the fluid is going to be coming out of this one single outlet, and it's going to be going crazy style, ultra fast, spray your kids, spray your dog, power wash a hole in the side of a tarp kind of fast, right? So hopefully this gains a little bit more of it helps you gain a little bit more of an intuition on how this works. If you have any questions, I'm pretty sure I'm presenting this, so you can ask them then. All right. Bye.